Hey everyone, and welcome. Today, we're going to dive in and demystify one of the most powerful features in Cisco ACI, Service Graph with Policy-Based Routing, or PBR for short. Look, if you've ever had to deal with the complex network gymnastics it takes to insert something like a firewall into your traffic flows, then this explainer is absolutely for you. We're going to break down how ACI automates and simplifies this whole process, which means more agility and way fewer headaches. So here's what we're going to cover. First, we'll talk about the problem PBR actually solves. Then we'll get into the universal ground rules that you always need to follow. After that, we'll compare the two main modes, Layer 3 versus Layer 1/2. We'll look at some actual supported designs, explore some advanced stuff, and just as importantly, what not to do. And we'll wrap it all up with a crucial concept called symmetric PBR and our key takeaways.
All right, let's jump right in. To really get why ACI Service Graph with PBR is such a big deal, we've got to first talk about the old way of doing things and the headaches that come with inserting services into a modern data center. It's a problem I'm sure many of you have run into.
You know the drill. Traditionally, trying to force traffic through a firewall or a load balancer is a huge pain. It usually means messing around with multiple VRFs and then trying to stitch them together with some really complex route leaking. Honestly, it's clunky to set up, a nightmare to manage, and when something breaks, good luck troubleshooting it. And this is exactly where ACI completely changes the game. Instead of all that manual configuration, Service Graph with PBR gives you a simple, policy-based model. You just define what you want to happen. Traffic goes from this client EPG through this firewall to that web EPG, and ACI handles all the complex traffic redirection for you, behind the scenes. It makes adding or changing services incredibly fast and way less prone to human error.
So now we know why we want to use it, let's get into the how. Before we start looking at cool designs and topologies, we have to cover the basic requirements. Think of these as the fundamental ground rules that apply to every single PBR setup in ACI, no matter what you're trying to build.
Okay, these are absolutely crucial. First, and this is non-negotiable, the ACI fabric has to be the default gateway for your servers. This is how ACI gets to intercept the traffic in the first place to enforce the policy. Also, it's super important to remember that PBR only works for unicast IP traffic. Your multicast and broadcast packets are just going to follow the normal forwarding path. And that brings me to a big warning. Be really careful with your contract filters. If you use a generic permit all, you could accidentally redirect things like ARP traffic, which you definitely do not want to do. Next up, let's break down the two main flavors of PBR. ACI gives you a couple of options depending on what kind of device you're trying to insert. And, you guessed it, each one has its own specific set of rules. So first, we have Layer 3 PBR. This is your go-to for standard routed devices, like a firewall that's acting as a router. The traffic gets redirected to a specific next-hop IP on that firewall. Now, a key thing to remember is that you have to explicitly tell the APIC controller the IP and MAC addresses for your firewall's interfaces, and this is important. If you're running a high-availability cluster of active firewalls, you're going to need a feature called symmetric PBR to make sure sessions don't break. Just keep in mind that requires newer hardware, the Nexus 3300EX or FX series switches. Now, on the other hand, we have Layer 1/2 PBR. This is for your transparent devices, things like an intrusion prevention system that just acts like a bump in the wire. As you can see, this mode is a bit more restrictive. It needs that same newer hardware. It has to be a physical device, not virtual. And for high availability, you can only do an active/standby pair. It also needs a two-arm design, meaning it has to have a separate physical in and out connection to the fabric. This slide really lays out the trade-offs perfectly, doesn't it? Layer 3 PBR is just way more flexible. It supports powerful features like vZANI, which is like a wildcard for applying policy to everything at once, and it can handle active-active HA clusters. Layer 1/2 PBR, on the other hand, is a much more specialized tool with some pretty strict hardware and design rules. The one you choose really just depends on the specific service you're trying to integrate. All right. Enough with the rules and lists. Let's look at some pictures and see how all this stuff actually comes together in common supported network designs. This is where we see the theory in action. Okay, this slide might look a little busy, but it shows the basics really well. Let's just focus on that top diagram, the one labeled 1. It's a simple case. You've got a client EPG and a web EPG. With PBR, ACI redirects the traffic from the client to the firewall's external interface, and the firewall sends it on to the web server. The other diagrams just show how you can chain services together,
maybe redirecting to a firewall first, which then forwards traffic through a second device like a load balancer. You can actually see the story of ACI's evolution right here on this slide. In that top example, which has been around since APIC 3.1, you'll notice the firewall's interfaces are in the same bridge domains as the client and web servers. That was a great simplification that got rid of needing extra service BDs. Then, the middle diagram shows how Release 4.1 added support for Layer 1.5 PBR. And finally, the bottom example shows that since Release 4.1.2, you can even have one side of your service connect to an L3 out, as long as the PBR policy isn't active on that side.
So what happens if your client and your web server are in different VRFs? Well, ACI handles this with a design that's often called a VRF sandwich. Now, for this to work, there's one critical piece. The subnets have to be leaked between the VRFs. You do this by setting the subnet's scope to shared between VRFs. This lets ACI in the first VRF know about the destination in the second VRF, which is absolutely necessary for the PBR policy to work correctly.
All right, let's move on to some of the more advanced things you can do with PBR. And, just as importantly, we're going to look at some common design mistakes and unsupported topologies that you really need to avoid.
Okay, this is incredibly powerful. Check out the diagram on the left. It shows two different EPGs, app and web, but they're both living in the same subnet. PBR can still intercept that traffic and send it to a firewall for inspection. The diagram on the right takes it even further. You can inspect traffic between two servers inside the very same EPG. This is a huge deal for microsegmentation, as it lets you apply security policy at the most granular level possible.
The VZ-Any object, as we mentioned earlier, is basically a wildcard that means any EPG in a given VRF. So on the left, you can see a contract where VZ-Any is the consumer talking to a shared service. That means all EPGs in the VRF get their traffic sent to the PBR node. On the right, VZ-Any is both the consumer and provider, which means you can redirect all traffic between any EPGs through a firewall. This just massively simplifies how you manage your policies.
You know, understanding what not to do is just as important as knowing what you can do. Getting this part wrong can lead to some really frustrating problems, like silent failures where traffic just isn't getting inspected and you don't know why. So let's look at some common mistakes. Here are a couple of big ones to avoid. First, in that top diagram, the PBR node is connected to bridge domains that have no subnet. They're layer 2 only. That's a no-go. The PBR node's BD has to be a layer 3 BD with an IP address. The other two diagrams show another critical rule. If you're chaining services together, you can't put a PBR node and the next service node in the same bridge domain. They have to be in separate logical containers inside ACI. And this is another huge gotcha. The crucial point here is that the actual interface where the PBR redirect policy is active cannot be an L3 out. An L3 out is ACI's name for a connection to the outside world, and PBR needs to happen inside a fabric bridge domain where ACI has full control. Now, you can't have an L3 out on the other side of your firewall, but the leg that's actually doing the redirection has to live inside the fabric.
All right, let's wrap this up by talking about a concept that is absolutely critical for any real-world deployment, especially when you're dealing with stateful devices like firewalls. We have to make sure that once a conversation starts, all the packets for that conversation follow the exact same path.
And that's exactly what symmetric PBR is all about. Imagine you have a cluster of active firewalls. You have to guarantee that the return traffic from a server goes back through the exact same firewall that the client request came through. Why? Because if it doesn't, that firewall won't know anything about the session and will just drop the traffic.
So how does it work? Well, it's pretty clever. ACI creates a mathematical hash based on the source IP, destination IP, and the protocol. That hash determines which firewall to send the traffic to. For the return traffic, the source and destination IPs are flipped, but the hashing algorithm is designed to produce the same result, ensuring the traffic lands on the very same node. Just like in the diagram, user 1's traffic gets hashed to the top firewall, and the return traffic follows that same path right back, keeping the session perfectly intact.
So if you only remember a few things from today, make it these 5 points. 1. The ACI fabric must be the gateway. 2. Always know your APIC version, because features change. 3. Know the different rules for Layer 3 versus Layer 1/2 PBR. 4. Stay away from those unsupported designs we talked about. And 5. For any stateful firewall, symmetric PBR isn't just nice to have, it is absolutely essential. So the next time you're faced with deploying a new firewall or an IPS, just think about how this kind of policy-driven automation could turn a really complex routing project into a simple, manageable, and repeatable service graph.